Okay, welcome everybody to the magnetic field due to a current carrying wire for Physics 231. For starters, I'm just going to show you the setup. And so what we have here is a wooden frame with a loop of current wound around it. You can probably only make out the top wire, but it goes all the way around in one square loop. We have our compass situated in the center of that loop, so we can detect change in magnetic field at that point. And as you can hopefully see from the video, the compass is oriented such that the north-south line is parallel to the loop of wire, and so the field that we generate through this loop of wire is going to run perpendicular to that. And then through vector addition, the B field of the Earth and the B field generated by the loop of wire will add together and point at an angle. And just to give you a quick view of what that looks like, so no current, and then as we increase the current, hopefully you can make out that the compass is rotating. And so back to zero current, and we're now back aligned with the Earth's field pointing north-south, a little bit askew from my coffee table. And then down here we have a current meter, just so we can get a more precise reading of the current that we're providing. And then we'll use a couple methods. The tangent method, which is discussed in your lab, which relates the B field, the final angle, and then that triangle you build through vector addition to solve for the field that we're adding. And then we'll also use the Biot-Savart law to again verify that what we find, or what I find in lab, is actually what we'd expect based on theory. So for the most part, I'll be providing you data. Again, it'll just be the angle of the compass and the current provided. And so turn this on, and again, as you see, as I increase current, the angle increases, and so we'll be using that information to solve for the final B field. And then we'll do, what I'll do after that is increase the number of turns. And so, as you can't see, but as it goes off camera, this wire is actually quite long. And so I'll wind it around 2, 3, and 4 times. And we'll again take measurements of the angle of the compass and calculate the B field that way. Based on turns, while holding the current constant, to see how the number of turns relates to the B field, just like we showed how current relates to the B field in the previous experiment. And then after that, there's a couple visual things where we'll wind a few one way and then a few turns the other way, and we'll see what kind of effect that has on the final field as well. So, I hope that gives you a gist of what we're doing. And then you'll receive data for the middle tables, and then you'll see a couple videos for 3 turns one way, 1 turn the other way, and then 2 turns one way, 2 turns the other way. And from those videos you can make observations and kind of see what's going on. So that's our plan for this week, and good luck.